I hope you guys are all having a great day. Today I'm going to talk to you guys about exercise physiology. Okay, I'm going to define what it is and give you guys some examples of the relationship between exercise physiology and exercise science. Note the important historic events that led up to the development of exercise physiology as a science discipline. Talk to you about the difference between chronic versus acute responses to exercise, and last but not least, tell you all about the important areas of studies in the field.
Hey, what's exercise physiology?
Hey Cameron, do you know what exercise physiology is?
Study and exercise.
Alright, so Cameron was sort of right. Exercise physiology is the study of the functional responses and adaptations that occur during and following the physical activity and exercise your body goes through. Exercise physiology can be used to enhance performance in athletic competition by improving the ways in which the body responds to training. And exercise science professionals such as coaches or trainers or athletes use training principles of exercise physiology to enhance the function of the various systems of the body. And identifying the factors that affect our bodies and affects our performance is the keystone in using exercise physiology to enhance that performance. Alright, so that's what exercise physiology is. Now let's talk a little bit about how exercise physiology came to be. It was established in 1891 at the Department of Anatomy, Physiology, and Physical Training School at Lawrence Scientific School within Harvard University. That program was a 4-year science-based curriculum, and that included classes in theory and in laboratory courses in exercise physiology. So furthermore, Springfield College and George Williams College adopted a similar program. But it wasn't until Harvard Fatigue Laboratory opened that did exercise physiology really establish itself as a scientific discipline. So, contradictory to what you probably would think, the closing of Harvard Fatigue Laboratory was really instrumental to facilitating the establishment of many other laboratories across the United States. And this was because the founders, the individuals who founded those new laboratories around the United States, they were really closely tied to Harvard Fatigue Laboratory. Okay, so beginning in the 1940s, there were several peer-reviewed journals that began publishing the experiments and the data from experiments in the physiologic responses to exercise. So that was one thing that further developed exercise physiology. And more came in response to a number of social, political, and professional factors, such as poor performance by American students in fitness tests and the competition between the United States and the Soviet Union to see who could first put a man in space and later on land a man on the moon. That really sparked the focus on fitness and performance for the United States population. History behind exercise physiology. Now let's get into the basis of the study. There are two primary areas, and one is how the body responds to acute episodes of physical activity, and the other is how it adapts to regular physical activity or chronic adaptations. Okay, so we all remember the term homeostasis back from high school biology maybe. But if you don't remember, it's just another name for the condition that our body is in its resting phase when everything is working together properly. It's important to understand how homeostasis works to understand what the differences are between acute responses versus chronic adaptations. The various systems in our body, they work together to maintain homeostasis, and when we put it through vigorous exercise, we disrupt its balance and disrupt homeostasis. The systems respond by either increasing or decreasing its activity levels. to get back to homeostasis. Okay, so repeated challenges to our body will result in chronic adaptation when it's done in appropriate intensity and duration and frequently enough. These adaptations are called training responses. Acute responses, on the other hand, are actions that occur in response to a single bout of physical activity. Okay, so that was one example of a bout of exercise or physical activity. So another example would be, for instance, someone taking a brisk walk on a hot summer day. They would have an increase in demand for energy productions in the active muscles that they're using. There's an increase in blood flow in the circulatory and the pulmonary system. There's an increase in body temperature, and then you produce sweat, and then that cools the body back down. So in general, the chronic adaptations to exercise improve various functions of the body, whether it is at rest or during physical work. So exercise science professionals really have to understand the acute responses and chronic adaptations the body incurs in order to build an optimal plan for an individual, whether it be for me or you or for an elite athlete. Exercise physiology contributes to a complete understanding of health, physical activity, exercise, sport, and athletic performance in a wide area that is too numerous to cover in this video, but here are a few of the primary areas. Exercise scientists and other allied health professionals have long been interested in the different factors that control energy production in the body during exercise. The energy sources, often called substrates, used by the body are carbohydrates, fats, and proteins. Understanding how the body tissues use these macronutrients to provide energy is critical to providing advice on how to enhance physical activity and exercise, and for providing recommendations to improve sport and athletic performance. At rest and in a post-absorptive state, the tissue of the body rely on fat and carbohydrate as the primary source of energy, with little energy provided from protein. However, the percentage of energy supplied to the body from carbs, fats, and proteins can be influenced by numerous factors. For example, eating meals of different macronutrient content can alter the energy sources utilized during rest and exercise. Implications for physical activity and exercise is another area of study. The control of factors affecting substrate metabolism has implications for exercise science professionals designing physical activity and exercise programs. For example, if the intention is to decrease body weight and body fat, then physical activity and exercise that promotes the use of fat as a substrate should be emphasized. It is often recommended that exercise intensity be kept low to promote the use of fat as fuel substrate because there is a greater percentage of fat utilized at low intensities. However, this recommendation does not take into account the total amount of energy expended during exercise session. At higher exercise intensities, more total fat could be used as a fuel source, even though the percentage of fat being utilized may be less than that which occurs at a lower intensity of exercise. Another consideration is whether the consumption of a pre-exercise meal or beverage high in carb is necessary. If a meal of glucose beverage is consumed too close to the start of exercise, there will likely be an increase in the insulin concentration in the blood, which will decrease the mobilization of fat and result in a reduction in the use of fat as a fuel substrate.